Okay, we're going to review some concepts and some problems about graphing polynomials. So first one says find the zeros of the following polynomial and state their multiplicities. So this is already in factored form. You can see all the factors 2x, x minus 3, and x plus 1. We could also count the degree of this polynomial, because here we have an x to the first. This is x squared, and this is x cubed. So add all those together, you have x cubed squared in first, so 3 plus 2 is 5 plus 1 is 6. So this has a degree of 6. Okay, and then I can set each factor equal to, each factor equal to 0 to find the zeros. So we set each factor equal to 0 and then solve. So we get x is equal to 0, x is equal to 3 when I add 3, and x is equal to -1. So these are my zeros. X equals 0, 3, and -1. And then your multiplicities is just the number of times you use. To get that, we look at the exponent. So 2x occurs 1, x to the first power. So this has a multiplicity of 1. X minus 3, there's 2 of them. It's x minus 3 squared, or x minus 3 times x minus 3. So that has a multiplicity of 2. In x plus 1, there's 3 of those, so that has a multiplicity of 3. In this next one, you're given the graph of the polynomial, and you want to state the zeros and multiplicities of each zero. So we're told it has a degree of 4, and then you can see the zeros. There's 1 here, 1 here, and 1 here. And this might be kind of hard to see, but each of these lines represents 1. So this happens at -2. This happens at -1. And this 0 happens at 3. So x equals -2 is a 0. X equals -1 is equal to 0. And x is equal to 3 is a 0. Okay, and then we need the multiplicities of each 0. So we have to do a little bit of guessing, checking here. Okay, so there's a degree of 4, and so the multiplicities need to add up to 4. And then as you look at the graph, notice that this 0, or the graph goes through this 0, but it bounces off of this 0. And the graph goes through this 0. So you got to kind of recognize the difference between going through a 0 and then bouncing off the axis for a 0. So if it goes through, then that means it's going to be an odd multiplicity. And if it bounces off, then this multiplicity has to be even. Okay, so that means this has to be odd. -2 and 3 both have to be odd. And the multiplicity at -1 has to be even. So for those to add up to 4, these both have a multiplicity of 1. And -1 has a multiplicity of 2. It might be a good idea to pause the video or even rewatch that and think about that again, because it takes a little while to figure out this pattern of going through and being odd and bouncing off being even for these x-intercepts. Okay, when we look at in behavior, we have some different things we look at to describe what happens on the right and what happens on the left. First, with notation. So as x goes to infinity, f of x does something. And then as x goes to -infinity, f of x does something. So, and I'm going to go ahead and write this in on both questions, because this is the same on every question. We're not really saying anything with this notation. All we're doing is kind of describing what we're talking about. So what does it mean? Well, this means on the right, the graph, and then you got to decide what it does. So, and you can determine what it does on the right by looking at the sign in front. So you look in the sign in front, and because it's negative, the leading coefficient is negative, then the graph goes down. So we're going to say it goes to negative infinity, and that means the graph goes down. So this blue writing is the interpretation of the notation we're using. What this means is on the left, I should say on right, on left, and then f of x is the graph, graph, and then it goes. Now, to find out what it does on the left, you look at the degree, or the biggest exponent. The biggest exponent is 4, and so that means it's even. If it's even, it is the same on both sides. Think about a parabola. A graph of x squared is u-shaped. So it's going to do the same on both sides. Same for 4th, 6th, x to the 8th. So because it goes down over here, it's going to go down over here. So notice how it's nice to find the right side first, because the left side you determine based on the right side. Okay, so we won't do the same, write out the same words here, but they apply. So we could say on the right, the graph goes blank. On the left, the graph goes blank. So on the right, the graph's going to go up because the leading coefficient, the number in front, is positive. And on the left, the graph is going to do the opposite because this is odd. The degree is odd, or the biggest exponent is odd. So it went up on the right. Odd means opposite. It must go down on the left. Okay, let's put this all together when we talk about this graph. Let's actually start by just talking about end behavior, since we just talked about it. So when we graph this, we could think about the end behavior. So as on the right, we know this graph is going to go up because 2 is the leading coefficient and it's positive. And on the left, we know this graph is going to go down because it is odd, which means opposite. So you're going to do the opposite as you did on the right. So we went up. That means we have to go down over here. So that means like this graph is going to have, I'm not going to sketch it in yet, but it's going to go up this way and then down this way. Okay, then we're going to find a 0. And to do this, you can use a graphing calculator. So plug into graphing calculator. And if you can find all the zeros, then I'm okay with you just doing it that way, right? Like you can find them all, great, that's fine. This one has one that might be tricky to see, but you should be able to see that x is equal to 5 is a 0. If you don't have a graphing calculator, then you're just doing trial and error. You're doing the possible zeros, which are all the factors of 15 over the factors of 2, and you find that 5 is a 0. Okay, so once you know 5 is a 0, you can put that on the graph, and you can also use synthetic division. So remember, 5 comes from looking at the graphing calculator. And then we bring this down and multiply. 14, what would that be? Hold on. 5, I did 2 times 7 instead of 5 times 7, sorry. 5 times 7 is 35. So how did I know I did something wrong? Well, you're supposed to get 0 at the end, and I saw that I wasn't going to get 0. So if you don't get 0 at the end, then you did something incorrect. So make sure you catch your error. I almost said be careful that you don't make a mistake with your division. Okay, so what does this mean? Okay, so x equals 5 is a 0. That means x minus 5 is a factor. And then you can write the other factor from your synthetic division. Remember, you go down 1, so it was x cubed. Now it's 2x squared. And then now we have to factor again. Let's just leave our x minus 5 out here. And you need 2 numbers that multiply to 6 and add to 7, and they are 1 and 6. And so we rewrite 7 as 6 plus 1x. And then factor by grouping. You can take out a oops, that's a 5, but you can take out a 2, x, and then a plus 1. So now we are fully factored, and I need to move that up so you can see it probably. So now we are fully factored. Once you're fully factored, you can find the zeros. So we have x equals 5, x equals -3 when we subtract 3 from the other side, and then x equals -1/2. Maybe we should, I'm going to write where these come from. So we set each factor equal to 0 and solve. And so that's kind of tough. But so you have factors here lead to these zeros. And we found all 3 of them. There should be 3 roots. And so we can sketch a graph. Put the zeros on. -1/2 is in between here. In between 0 and -1. And then the graph doesn't have to be exact, but you know it's going to go down on the left. So it's going to come up this way. And it's going to go up for a ways and actually goes off this graph and then back down and then back up. All the multiplicities are 1, so it goes through each of these, and that's not a very good sketch. But you get the idea, and we are just sketching these graphs. They do not have to be exact. But what we're looking for is the general shape of the graph and then the zeros being in the right spot. Okay, good luck with graphing polynomials, and reach out if you have questions. This is tough stuff. There's a lot in one problem. I think you could argue that like this question here is almost a complete test, right? It covers so many concepts. So make sure that if you have questions, reach out.